Hello, we are group number three, and we did our database on a hospital network. And our group includes myself, Sven, and we also had Daniel, Harris, and Isabel.
All right, I'm Daniel. I'll be leading you all through our story. We wanted to focus on a real world problem that almost everyone gets affected by. And that idea brought us to wanting to work on how hospitals manage patient information. And so that in turn brought us to wanting to work on a hospital network database as our problem and our solution. Hospitals deal with a huge amount of data every day. Things like patient records, staff assignments, appointments, medications, and room availability. In many cases, this information is spread across different systems or handled inefficiently, which can lead to delays, confusion, or even mistakes. Our goal was to design a centralized database system that brings all this information together into one place. This allows hospitals to better track patients, manage staff, monitor capacity, and support decision making.
My name is Harris, and I'll be in charge of the database schema. And so, as you can see, here's our database, as it shows all of like our tables, such as like diagnosis, appointments, patients, staff, hospitals, as a hospital database would have. And so, the main thing through our project was that we noticed was that the four key entities were patients, staff, hospitals, and appointments, mainly because patients were touched by nearly every table. Staff was the main one that drove appointments, diagnosis, and treatments. And then the hospitals were just the organizational like anchor for everything. And appointments were just the primary interaction between patients and staff. And then some examples of relationships that we dealt with was the ones on the screen, as you can see, it's like staff works at hospital, or patients are treated at hospitals, or staff conducts appointments, stuff along those lines. We noticed that the main primary keys were connected by appointments. Appointments was the main foreign key that tied all four together. Um, and our core functionality of our schema was patient management, as it just registered and identified patients, tracked their records and stuff like that. Hospital admin, as it just tracked and managed multiple hospitals and organized departments within those hospitals. And then admissions and discharge, where you're admitting patients, making sure they get the proper treatment, and then discharging them appropriately.
Hello, my name is Isabel, and I'll be going over the implementation of our database. As shown here, we have the business logic that got implemented as per our proposal, and we implemented almost all of them. Unfortunately, we misimplemented one of our business logics that required us to have a weak entity named prescriptions. We ended up making that a strong entity just to be able to more readily keep track of all prescriptions that were handed out in the database system. Um, if you don't mind. Next one. So the main capability of our database is to be able to run a smooth hospital system with running correct queries. And our database was designed to behave as a relational database where the schema is static and the entities are object-based entities. And we used Superbase as our main implementation of our database. And we also attempted to implement an API layer, but ran into routing issues with TypeScript files in our system. We made our database in Superbase by taking the DBML file of the previously shown schema and making it into a SQL file. And we made tables by yourself for those files. And on the next slide, there's an example of one of our tables. It's the patients table that was previously mentioned, and in total, we ended up with 17 tables for our database. And on the next slide is an example of one of our queries being ran with the generated data that we had made for this database, which was generated as CVS files that was then imported into Supabase and later transformed into SQL files.
And so in reflection, some things we learned is we learned how to implement a database based on a real world problem, which was the hospital network. And we also learned designing relationships were a lot more complicated than we expected, especially with something as complicated as a hospital network. And we also gained experience in writing valuable SQL queries to get information we needed from the database. And so, some of the challenges we faced and something we want to implement in the future would be an API layer. And something else we'd also like to do is to implement our database into a real world hospital network. And another challenge was scoping because something as complicated as a hospital network, the domain is so wide, so it was hard to choose which entities we wanted to include and which entities we did not want to include. And thank you so much for watching.